Hello everyone. In this section, we are going to learn how we can orchestrate our Docker containers on multiple hosts using Docker Swarm. This is an introduction to this section. So, what is Docker Swarm? It is Docker's native clustering solution. It comes pre-installed with Docker. You don't need to install it. It's natively installed with the standard Docker package. It is used to orchestrate containers on a single or multiple hosts. So this is a very important difference between Docker Swarm and Docker Compose that we covered in the previous section. Using Docker Swarm, you can create a cluster that provides high availability and fault tolerance for the hosted applications. In this section, we are going to learn how we can create a full, highly available microservices architecture. At first, we are going to initialize the cluster and have Node.js application that we have covered before up and running. Then we are going to augment this Node.js application with a middleware layer. We are going to use Python Flask as another API in our application so that we can mimic a real-world microservices architecture. Finally, we are going to examine the fault tolerance capabilities of the cluster by adding an additional node to the swarm and experiment with bringing down other nodes and see how the cluster behaves in case of one node down. In this video, we are going to learn how we can set up Node.js API on Docker Swarm. We have here an instance. This could be a virtual machine on your host, it can be a bare metal machine, it can be any machine that is running Linux or that is capable of running Docker. And I've already installed Docker on this machine, so if I run Docker -- version, I can see that it is installed, and that is the only prerequisite for Docker Swarm to run. When Docker Swarm is initialized, the first node that it gets initialized on is called the manager node. So let's ensure that our Docker service is running. And I'm going to initialize the swarm by using sudo docker swarm init, just like that. Okay. Now we have very important information that is added to the screen. Swarm initialized current node, and it's giving me the hash of the node is now manager, because this is the first node on which we initialized the cluster. And now we have this command. We will need to copy it. This is the command that is going to be used to add any worker nodes to the cluster. A worker node is the node that will carry the services, like, for example, a web server, an API, any services that this cluster is going to serve is going to be served on worker nodes. However, the manager node can also assume worker node role. So this node can act as a manager and at the same time as a worker. So I'm using AWS infrastructure here, but again, this can be done on a virtual machine, on VirtualBox, VMware, bare metal. The most important thing to notice is that your nodes should have all traffic enabled between them. So I have here a manager node, I have a worker node, and I have configured the network between those two nodes that all the traffic between them inside the internal network is enabled. No firewall, no VLANs, nothing is blocking the traffic between those two nodes. This is important for your cluster to work correctly. So now I have the manager node ready. I'm going to log into my worker nodes. So I'm going to open a new terminal window. Right, I'm inside. Let's install Docker. Okay, let's start the service. Right, now let's paste the command that we have copied from the manager node and paste it on this node. Of course, I need to use sudo. Okay, this node joined a swarm as a worker. So now I have a manager and I have a worker. A good idea to rename your machine so that it reflects its role. So sudo hostname ctl set hostname exit and reopen the SSH session so that our changes are reflected. So now I have a manager. So the same thing here. Now we have a worker. Now we need to initialize our cluster with a Docker container or a Docker image so that our cluster has something to serve. Luckily, you don't need to learn anything new. You can just use the knowledge that you gained in the previous section when we discussed Docker Compose. You can use the compose file, roughly as it is, to initialize a swarm. So I'm going to create a file that is called dockercompose.yml, docker-compose.yml. Let's quickly write the same version of our Docker Compose file. Okay, so this is the same Docker Compose file that we used before. And now let's see how we can initialize the cluster with this Docker Compose file. So sudo docker stack deploy. Then we can give a stack name. We have to give a stack name. The stack here is another name for the cluster. So Docker calls a cluster a stack. So it's Docker stack, then deploy, then give it a name. Let's call it Node.js API -c. Then give it the name of the Docker Compose file. It's docker-compose.yml, and hit enter. Notice here that it is ignoring unsupported options restarts. That's why I said that the Docker Compose file is roughly the same as the Docker Compose file used for the Docker Swarm or the Docker Stack. There are minor differences here, like for example, the restart is ignored. That's because Docker Swarm by default manages your containers. It manages them if they are down. It's going to restart them. It's going to schedule them on other nodes if the node got down, as we're going to see, and so on. So now we have our cluster up and running. Let's have a look at what got installed or what got deployed. Sudo docker service ls. Now remember in the previous section when we said that Docker Compose calls the container services, well, Docker Stack has the same terminology, so a service is another name for the container. Let's issue this command and let's have a look here. We have our Node.js _db. This is the name that the stack gave for the container automatically. And have a look here at the mode. It's replicated with one replica. We're going to cover replicas later in this section. But notice here that you didn't need to do anything other than supplying the Docker Compose file and issuing the Docker stack deploy command. Now the cluster is managing your application. It's managing the MongoDB, the Node.js API. If I did our old Docker container ls, I'm going to see that I have one of the containers hosted here, which is the node. If I go to the other worker node, sudo docker container ls, I'm going to see that I have here the MongoDB database. So Docker Swarm has intelligently distributed your workload on both of your nodes. So one node is carrying or serving the Node.js API, the other one is serving the database. What if I want to run this same command that I ran on the manager on the worker? For example, sudo docker service ls. I'm going to have an error because only the Swarm manager is allowed to have these commands run on. So if I try to run any of the manager commands on a worker node, they won't work. You have to run them on the manager node. So that is one key difference between a manager node and a worker node. And as we said before, a manager node is capable of running containers the same as worker nodes. Another command that you can use to diagnose your containers or your services if they have any errors is docker stack ps, then give it the name of your stack. We named it Node.js API. This will give you some more details about the services or the containers and where they are running. So here, look, we have here the node. So you know now that Mongo is running on worker 1 and Node.js is working on the manager. So I hope now you have a clear idea about Docker Swarm, what it is, how to deploy a service or a number of services on a swarm, and how it manages your containers automatically by distributing them on multiple nodes.